So here's another part of the adding and subtracting using scientific notation. As a review, what we did yesterday, and by yesterday I mean
500 days ago.
Friday. It was Friday. We had to make sure that we had the same exponent before manipulating it. So what we would have to do is we would have to adjust our decimal. We would have to adjust our decimal to make sure that we have the same exponent for adding. Okay? We had to adjust the decimal to make it same adding. So if we had a 6 here, we could go one of two ways. We could make it be 10 to the 4th, or we could make the other one 10 to the 6th. The bottom line is you have to be dealing with the same exponents. So subtracting. General rule form for subtracting is for any number n times 10 to the power of x, or n to the x, 10 to the x power, minus m times 10 to the x power. You need to make sure that you can have them both be the same, so that x is going to be the same number. So it's n minus m. So n as in Nancy minus m as in Montana. The first step, if necessary, is to change one of the numbers so that both numbers have the same exponential value, just like adding. Second, we subtract the coefficient. This is the same thing as adding, just take away adding, or take away adding from your notes above it and make subtracting. Okay? The final step is to multiply the result by the 10 to the power of x. It may be necessary to put the resulting answer into proper scientific notation. I don't know why we wouldn't do that, considering that's what we're studying. Yes, sir?
What's the coefficient?
The coefficient is the number that is being multiplied by, I'll show you. Oh, wrong button. Coefficient, that one is 6. So it's whatever's being multiplied by the others. Cool? So it's essentially the same thing as adding, just the word subtracting in there. Yes, sir?
Okay, so I'm not trying to do that.
It doesn't bother me. It's much better than weight.
Oh. So if you had 6 times 10 times 4, what would it be? 6 times 4?
It would be a common factor, which would be 2, but the coefficient is n minus m. You see how these two numbers are going to be multiplied by 10 to the x? N by itself on the left is not a coefficient. M by itself is not a coefficient by itself, but once these two are together, it is, because it's being multiplied by a second thing. Just that's not here. See if you can find it in here. Yeah. Aiden?
Do you ever figure out when the ladder method doesn't work?
It wasn't common factors. Wasn't that what when it's a factor? Okay. Okay.
You disprove the theory.
Okay. So subtracting with the same exponent. It's not. Darn. Gotta look in the back of the book. The numerical part of an algebraic term. So in this situation, we have the same exponent, which is 10. So all we have to do is just subtract 8.96 subtract 3.41 from 8.96. It has the same exponent, so we don't have to make any changes. Yes?
Why is it 10 to the 7? Wouldn't it be 10 to the first? No, 10. The 7 minus 7. When you subtract those,
Remember, when you subtract exponents because of the exponential law of division, that's when you subtract them.
so you wouldn't do anything.
Right. It stays the same. That's that 10 to the x. Also, nobody got the bonus question right on the quiz. Off the top of my head, u squared a to the 7th, I think.
Did anyone get an A plus on the quiz?
I'm not done grading them yet. I have one more page to do.
Whether it's 10 times 6 times 10.
What was your expect tomorrow?
That's not an algebraic expression. That's just
So there would be no
right. So here's it with different exponents. Now we have different exponents. This right here is a 2. This right here is a 3. We have to have them be the exact same. You could have it be going either way. You could have them both be 10 to the 3rd or 10 cubed or 10 squared. And in this situation, we chose to do 10 squared. And remember when we were doing on Friday, when we made a number from scientific form, it's however far the decimal place is moving, zeros to up or down. And whenever we moved the decimal place from the left to the right, it went down. So we moved it to the left to go down, 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 to down, 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 to down. So once we have the same exponent, now we could just subtract like we're in 2nd grade, or subtract because it's decimals like we're in 6th grade. Yeah, it's when they first do that, yep. There's 4 different rules to remember when you're doing decimals that you guys just make sense to you. Line up the decimals, put 0 in as placeholders. That's why this is accelerated. It is easy for you. No, you don't interrupt me by saying, wait. I'm not smiling. What's your question?
So if you're multiplying something by like 20 or 110, can you just skip the whole first number because it's 0 and it's write a 0 as a placeholder?
Yeah, that's exactly what I do in my head whenever I do mental math like that. Yes, sir.
Why does it happen when you get from 10 to the 3rd to
It was, let's see. It was this stuff where we went, whenever we adjusted to get 9.4 times 10 to the negative 3, if we wanted to make that 10 to the negative, if we wanted to make that 10 to the negative 2, it would move to the, let's see here. So when it goes from small to big, it goes to the right, and we were making it go 94. Wait a second. Okay. So here we have 6.92. This is a better example. 6.92 times 10 to the 4th is actually this number. And if we wanted to do 69.2, that would be 10 to the 3rd. Yeah, 3rd. Because it would be from here, 1, 2, 3. See how these are all the same number? If it was 69.2 times 10 to the, get out of there, times 10 to the negative times 10 to the third is the same as 6.92 times 10 to the fourth. These are both going to come out to be this. It's just this bottom one here isn't proper scientific form, but we have to make sure that we have the same exponent before we add or subtract our scientific notation. Amul? If you change these to a 3 instead, is that what you're saying? You would still get the same answer at the end. Because you'd want to have it be in proper form, which is going to be a single ones digit and then decimals after that. Yep. Good. Let's look at the homework and do some examples from that. Yes. What's your question? Well, yeah. Now these numbers are really weird. How these are numbered. For some reason it goes 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. I don't know. Maybe originally this was part of a. Wait a second. Okay.
Will we have a final response?
That is undetermined at this point.
That's my last.
Pre-algebra has a final every quarter. Could you put it with the books for me? You're welcome. You're welcome. All right, we are going to do number 1 on the front side together. As indicated by having the hole punches on the left side. So we have 2.3 times 10 to the fourth, in parentheses, plus 4.16 times 10 to the seventh. I want these all to be the same exponent, and I can go high or I can go low. So I'm going to make the adjustment for, let's see, in the notes, did they like to go low or high? They went to the lower one. So I need to make this guy be 10 to the fourth. Since my exponential value is getting smaller, that means that my decimal has to move to the left or right? To the right. 1, 2, 3 spots. So I now have 4,160 times 10 to the fourth. I'm going to verify that I'm doing that right here. So I have 1, 2, 3, 4, 5, 6, 7. 4,160 times 10 to the fourth. 1. Let's see here. Okay, then 1, 2, 3, 4. Good. I know that I did that right. I just put this guy as here. That's a bad one. Okay. This one is here. See how it's the same number? If you're unsure if you're doing the correct scientific notation adjustment, write it out like that. So now that I have the same exponents, now I can jump into action. let me. Thank you. All right. So now I have 2.3 times 10 to the fourth plus 4,160 times 10 to the fourth. So that's just going to be 4,162.3 times 10 to the fourth. Now, is that in proper scientific notation? No, it is not. So I have to move the decimal 1, 2, 3 spots over here. So what's that new exponent going to be? Mm-hmm. I moved, see my red writing? It moved to the left 3 spots. Okay, so that was number 1. Stacy? Why what? Because this one here was not in proper scientific notation. Scientific notation is going to be a number, a decimal point, and then decimals. You have a, oops, well, hope you guys are done with that because I just accidentally deleted it. So yeah, it's because it has to be a single digit in the ones digit, then the rest are decimals. Let's do number 3 you wanted to try?
Yeah.
Okay. Number 3 is 6.07 times 10 to the negative 1 plus, you guys like the color on black background?
Yeah, I really like.
Okay. Oops, that's minus. Minus 4.52 times 10 to the negative 2. Oops. I need to make these both the same coefficient. I need to make them both the same coefficient, so I'm going to go up. I'm going to go up so it's negative 1. So I'm going to make this decimal point go to the right 1 spot.
Oh, so you follow the same rules with negative.
Even if it's subtraction. Yep.
No, like negative.
Yep. That's not it. That's just how I'm doing it. Either way, you could change the first one or the second one. It doesn't matter. You could work on the left if you'd like to, as long as you have the same exponent. Yes? So let's double check. I'm going to make sure they did that right. I have 4.52 times 10 to the negative 2. So times 10 to the negative 2 makes it go to the left. 1, 2. So I should have that. 45.2 times 10 to the negative 1 would be 5.2 times 10 to the negative 1. Yep, so I didn't do that one right. See how I double checked myself to make sure? Good. So let's make that right. When we went to the other direction, we should have it be that way, right? So this is not there. This is here. Oops. A little bit big. There we go. So now I have 4.52 times 10 to the negative 2, which would be 1, 2. Then I have 45.2, Or 0.45 times 2 goes over 1. Now I'm good. Now I'm in business.
So it's negative, you reverse it. It's a negative exponent.
If I'm getting smaller, the exponent gets bigger. And that was the notes that we took the other day. Once I drop out of this, I'll show you what I mean.
Oh, okay. I got it.
So I have 6.7 minus 452. And it's already in scientific notation, so I'm good. Possibly, yes. You said a lot of numbers behind it. This doesn't have a lot of numbers. It's just our area code. It could be 1. It can be infinite. Like 1.0 times 10 to the 1. 1.0. It has to be a single digit, a decimal. That's scientific notation, yes. Okay? Yes?
What would you do if there was a negative and positive exponent?
You just need to make them the same.
Would you take the positive exponent and lower it down to the negative one? Or would
You
go
can.
to the left or right?
You can go, it's just as long as you make one go higher to go up the next one, or you're here, the other one gets lower.
Yeah, it doesn't have to be.
So this one we went higher. Yeah, that's good. Has everybody got that? Okay. Feel free to continue going. I'm going to do another example. So you can start that homework. And you want to get lower? Or you want to go, because we went higher the last week, so you want to go lower one? Okay. So we're going to go to the lower one, so we're going to bring it to being 6. There's only a couple number 6s.
Oh, right.
I'm on number 6, duh.
There are kind of a lot.
The second 6. So I want to go from being 9.67 times 10 to the 9th to 9.67 times 10 to the 6th. Because I'm dropping down more, it's going to be a change of 3. So I'm going to go 1, 2, 3. I'm going to verify that I'm doing that correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I go the wrong direction again? I did. Gosh darn it.
Is the number getting lower, the
Yes.
exponent gets higher?
The number gets lower, the exponent gets higher. I went the wrong direction. Darn it. See, this is because I don't have my notes out in front of me. Case in point, have your notes out in front of you when you're doing this so you don't make the mistakes that I'm just making right now. There we go.
Wow, that's a big number.
So that's 6, 7, 0, and I'm going to have 1, 2, 3, 4, 5, 6. I'm good. That is the same number. Any questions? Yes. The zero, the placeholder? Yeah, make sure zero has a placeholder. Okay. Does anybody not have this one? Okay. Yes. So this would have to drop by from 2 to 1 to 0 to -1. It's dropping 3 spots. So your decimal is going to go to the right 3 spots on this one. You're right, yes. Sorry, I meant this one. So it's going to move to the right 3 spots. Your decimal, this right here, looked like a percentage sign. I was like, what? So when the exponent gets lower, move the decimal point that many places to the right. So if you had to go lower by 3, it would move to the right by 3. And in contrast, when it gets higher, you move down places to the left. Yes, sir. Please do not use pen. No. No. So get your pencil out and use that.